Hi everyone. Today we will be graphing logarithms in our fourth day of Unit 5. So our objectives are to describe transformations and describe characteristics and also to graph. So for the first part, just wanted to quickly review what we looked at in the Desmos activity. Remember, exponential functions have a domain of all real numbers, as you can see in the blue graph, a range from 0 to infinity, and we have these key points, the y-intercept, which is 0, 1, and the base point, which is 1b, whatever that would be. So we'll just say that is 1b. And then an inverse is when you reverse x and y, or switch x and y, reflected over the line y equals x is another way to think of it. And so for the inverse, we'll be looking at the log, where the domain becomes the range. The range is the domain, and then our key points also reverse coordinates. So we have an x-intercept 0, 1, and a base point of 1, 0, and a base point of b1. So b1 would be like that. So go ahead and make sure you have all that down. See how they're connected. And then on the next page, go ahead and try filling in the section about the exponential. And then I'll show you that when I move to that screen, and then we'll reverse everything to do the log. Oh, I'm just kidding. I forgot about this. This is the log information, so make sure you have all of this written down. I think only the domain and range were empty, so go ahead and fill them in. Pause if you need to get the rest if you don't have the notes printed. And then on the next page, go ahead and try filling in the exponential column with the end behavior, and then hit pause to see the answers. Okay, so everything in blue you should have already known how to do, so that's why it's already done, and make sure you just check your work and see that you got it. And then in pink, we'll just reverse everything. The range becomes 0 to infinity, the range becomes the domain of 0 to infinity, the domain becomes the range of negative infinity, positive infinity. Now we have an x-intercept at 1, 0, because this flipped, and there's no y-intercept, because we have a vertical asymptote now. So I'm going to draw that. And we have our base point would be 2, 1. So 1, 0, 2, 1. And now it goes really close to the vertical asymptote and then flips off to the right. And so we don't have an end behavior on the left. X does not approach negative infinity, but it does approach positive infinity. And that's because of the asymptote. It does not approach that negative infinity. And even though it's slower, it's definitely going to approach infinity in general. It's still increasing indefinitely. So the other thing is called vertical asymptote behavior. And so we've done this before with rational expressions. We have the limit as x approaches the vertical asymptote. This case, there's only a right side. We put the little plus for the right, and our function goes to negative infinity on the right side of the vertical asymptote. Hopefully you saw why when you looked into the Desmos activity to see how the different x and y values connect between the exponential and the logs. So there is no left side. There is no negative infinity. So those are the two things that we would do for the log function. We'll put it all together in the next couple of pages. Here's just a quick refresher about inverse of natural log is e, and the inverse of common log, remember, any log that's just log of x, it has a base of 10. Automatically, ln is log with a base of e. So don't forget that. So we should recognize that those are inverses of each other. Next, let's describe some transformations. You can go ahead and pause this to try that, or if you want to just follow along with me, that's fine. Remember, we always go from the inside out. I like to highlight the inside with a yellow box and then describe them from there using order of operations. So this one would be left 2, And then we have a vertical stretch by 3. This next one, this is the inside. We need to rewrite this so that we take out the negative and rewrite it like x minus 1 like that. And so now that's really the inside. And so if we do this, we have a reflect over the y-axis and right 1. And then this last one, we have left 4. And then we can go reflect over the x-axis since that's outside. And vertical stretch by 2. We're going to focus on that last one to graph. And so we have the same thing. Remember, it was left 4, reflect over y-axis, over x-axis, and vertical stretch by 2. So we'll use the same method that we did before. I like to make a table for the key points. They are 1, 0, and B, 1. That's your base, 5. So now that we have all the transformations written down and we have our key points, 1, 0, and 5, 1, we'll apply the transformations. To move left 4, we subtract 4 from the x value since it's a horizontal move. And so that will be over here. I'll do minus 4. 1 minus 4 is negative 3. 5 minus 4 is 1. To do the reflection and the vertical stretch, we can do that all at once. We will multiply. This is something that happens to the y values by negative 2. And so that's kind of what's happening is the y values are being multiplied by negative 2. And so 0 times negative 2 is 0. 1 times negative 2 is negative 2. And so now we will plot our new points. We'll make them green. Negative 3, 0. And 1, negative 2. Remember, our vertical asymptote got moved 4 units to the left as well. So I'm going to add that in right here. It was x equals 0, and then it got moved to the left 4. So it should be right there. And then the way that these get graphed is they go along the vertical asymptote, not touching it technically. Ooh, not like that. And then they come down and to the left, or typically they go up and to the right, but when this one got reflected over the x-axis, that's why it got shifted. No, not reflected, but reflected vertically like that. So then the domain, you can see that it goes from negative 4 from the asymptote to infinity. I can see that in my picture. The range, also you can't take the log of a negative, and so negative 4 is the lowest number it could be, and log of 0 is undefined. The range, I can see it has an up arrow and a down arrow, so it's negative infinity, positive infinity. That's always the case for logs. Then remember, end behavior, there's no left side, so we only have x approaching positive infinity. And then the function is going negative since it got flipped. And the vertical asymptote behavior is at negative 4 from the right. And on the right side, the graph is going up. And so there's an overall view of the logs. They're very similar to graphing exponentials, except basically everything got flipped. Hopefully you noticed that, and we're able to connect the two. So take everything we did from exponentials and flip x and y. And we do have this new thing with the vertical asymptote behavior since there's no left side of the graph. All right, I hope you guys have a great day. Make sure to check your Canvas asynchronous column for what's next. We'll see you